All right, let's talk about our solar system. Today, we're taking a trip through our cosmic backyard to see how our understanding of it has completely changed over the centuries. It's a really cool story of discovery, big ideas, and, well, being wrong for a very long time. Okay, let's jump in.
So, to kick things off, here's a wild thought. For most of human history, we were absolutely convinced that we were the center of everything. The whole universe literally revolved around us. Now, that sounds kind of silly today, but figuring out why people believe that for so long, that's where our story really begins.
So, let's start at the beginning, in the ancient world with a model of the cosmos that put us right in the middle of it all.
Now, you have to remember, before telescopes, all you had were your own two eyes. And that's a huge limitation, right? It meant the farthest planets, almost all of the moons, and countless asteroids were just invisible. Our view of the universe was shaped by what we could see, and we just couldn't see the whole picture.
And that's what gave rise to the Ptolemaic model, named after the astronomer Ptolemy. It was this hugely influential idea, a geocentric or Earth-centered system. The thinking was that everything, the sun, the moon, all the planets we could see, they all orbited us.
And get this wasn't just some passing fad. Look at this timeline. For over 1,300 years, this was the accepted truth. It was more than science. It was the fundamental way people saw their place in the universe. And as astronomers got better at observing, they had to invent these ridiculously complex loops and circles just to make the math fit, all to keep Earth at the center.
But then came a total game changer. An idea so revolutionary it would flip our perspective on everything and put the sun right back where it belongs.
And this slide just lays it out perfectly. On one side, you have that old, clunky, complicated geocentric model. And on the other, you have the heliocentric, or sun-centered model from Copernicus. It was simpler, it was more elegant, and when the telescope was finally invented, the observations proved he was right all along.
So now that we have our map oriented correctly, let's take a quick tour of our cosmic neighborhood. What's actually out there?
Well, our solar system is completely dominated by the sun. Its massive gravity holds this whole cosmic family together. We've got the 8 planets, hundreds of moons, a growing list of dwarf planets, and all the smaller stuff, the cosmic debris like asteroids and comets.
And the variety out there is just staggering. I mean, just look at Mercury, the closest planet, and Neptune, the farthest. Mercury is a scorching 430 degrees Celsius and zips around the sun in just 88 days. Neptune, on the other hand, is a frigid -200, and one of its years takes 165 of our years. It's just a perfect reminder that in a solar system, distance from the star is everything.
And it's not just the big planets. We also have asteroids, which are basically giant space rocks. And then we have comets, which are more like dusty snowballs. The really cool thing about comets is that when they get close to the sun, their ice starts to vaporize, creating that beautiful glowing tail that we can sometimes see from Earth.
Okay, so we know it's out there, but how does it all stay in place? What's the unseen force that's choreographing this entire cosmic dance?
The answer, of course, is gravity. It's the universal glue. It's the force of attraction that's constantly pulling everything toward the sun, keeping all the planets from just flying off into the emptiness of deep space.
You know, think about swinging a ball on a string. You're constantly pulling the string inward to keep the ball going in a circle. That inward pull, that's the centripetal force. In the solar system, there's no string. Gravity is the string, constantly pulling the planets toward the center.
So how do you get a stable orbit? It's all about finding that perfect sweet spot, a delicate balance between speed and gravity. If you're going too fast, you'll break free from gravity's pull and just keep going. If you're too slow, gravity wins and you'll get pulled in. But if your speed is just right, you're basically falling around the object forever. That's an orbit.
And we use this exact principle for our own artificial satellites. You have low, super-fast polar orbits that zip over the poles, mapping the entire planet. And then you have geostationary orbits, which are way, way higher up. They move slower, matching Earth's rotation perfectly, so they seem to just hang in one spot. That's what makes things like GPS and satellite TV possible.
This all brings us to a perfect final point about how science actually works. Our understanding is never set in stone. It's always evolving. And there is no better example of this than the story of Pluto.
Many of us grew up learning there were 9 planets. Pluto, found in 1930, was our distant, icy 9th member of the club. But then, in 2006, scientists officially changed its status. So, why did Pluto get demoted? Well, it turns out that as we started discovering more and more objects out there, our definition of planet needed an upgrade.
So here's the rule that changed everything. A planet has to do two main things. One, be big enough for its own gravity to pull it into a round shape. And two, this is the big one, it has to be the gravitational bully of its own orbit, powerful enough to have cleared out all the other space rocks. Pluto checks the first box, it's round, but it fails the second one. Its orbit is full of other icy objects, and that's why it got the new title, Dwarf Planet.
And that's really the most important takeaway here. From an Earth-centered model to a Sun-centered one, from 9 planets down to 8, science isn't about finding final, unchanging answers. It's a process. It's a story of constantly refining our map of the universe as we learn more.
So as we look out into the cosmos, the map we have today is the most detailed one we've ever had. But if history has taught us anything, it's that the map can and absolutely will be redrawn. The only question is, what discovery is going to be the one to change it next?